Picture a massive galaxy cluster, hundreds or even thousands of times larger than our own Milky Way, and imagine it's sitting in the middle of space like a cosmic magnifying glass. Well, in a sense, that's exactly what these galaxy clusters are doing. They're bending light and distorting the images of galaxies that lie behind them. It's a phenomenon known as gravitational lensing, and it lets us see some extremely distant galaxies that would otherwise be impossible for even the largest and most powerful telescopes to detect. But it does so much more than that. Gravitational lensing also allows astronomers to confirm one of Einstein's predictions about his theory of relativity. It helps them map the distribution of dark matter throughout the universe, and it creates some absolutely stunning images of galaxies that are literally millions of light years away. These cosmic magnifying glasses are helping astronomers solve some of the biggest mysteries of the universe. So let's take a closer look at them. Massive galaxy clusters have a tremendous amount of mass, and that means they have a strong gravitational pull. Light bends in the presence of gravity, so the light from distant galaxies gets bent as well when it passes by these massive clusters. This bending of light is called gravitational lensing. The effect can be so strong that entire galaxies can appear distorted and stretched out like pieces of spaghetti. And because these galaxies are so far away, we can see them as they existed billions of years ago. This allows astronomers to study the evolution of galaxies over time and get a better understanding of how the universe has changed since the Big Bang. But gravitational lensing does more than just distort the images of background galaxies. It can also magnify them. When the gravity of a galaxy cluster is strong enough, it can actually focus light from a background galaxy into a small circle. And when viewed through a telescope, this circle appears as a bright ring around the massive galaxy cluster. This phenomenon is known as an Einstein ring, named after Albert Einstein because it was predicted by his theory of general relativity. Einstein's theory says that massive objects warp the fabric of spacetime around them, and this warping causes light to bend. Gravitational lensing was one of the first tests of Einstein's theory, and the fact that it was confirmed by observations of these massive galaxy clusters provided strong evidence in support of the theory. But gravitational lensing doesn't always produce a complete ring. Sometimes the image of a galaxy is only partially visible, appearing as an arc or a lenticular shape. This happens when the galaxy cluster is not perfectly aligned with the background galaxy. But no matter what shape it takes, gravitational lensing can make distant galaxies appear up to billions of times brighter than they would without the help of the massive galaxy cluster acting as a cosmic magnifying glass. This makes it possible for astronomers to study galaxies that are literally billions of light years away. And it gives them a unique window into the early days of the universe when galaxies were just beginning to form. One of the most famous examples of gravitational lensing is the galaxy cluster known as a Bell 2218. This massive cluster is located about 18 million light years away and contains hundreds of galaxies. The combined gravity of all these galaxies distorts and magnifies the light from a background galaxy, creating a giant Einstein ring. This particular example was one of the first to be discovered, and it has been studied extensively by astronomers. It has helped them learn more about the properties of dark matter and the distribution of matter in the early universe. And it's also given us an incredible view of some of the earliest galaxies ever seen. But gravitational lensing isn't just interesting for what we can see, it can also tell us what's not there. By studying the distribution of galaxies that are magnified by gravitational lensing, astronomers can map the distribution of dark matter in the universe. Dark matter is an invisible substance that makes up a large percentage of the mass in the universe. It doesn't interact with normal matter, so it's impossible to see directly. But we know it's there because of its gravitational effects. By studying the way that light is distorted by massive galaxy clusters, astronomers can map the distribution of dark matter in the universe. This is because dark matter has a gravitational pull, and that gravitational pull affects the way that light bends. By studying these distortions, astronomers can create maps of the distribution of dark matter in the universe. This is helping them learn more about the composition of the universe and the fundamental nature of reality itself. And while all of these scientific applications are incredibly important, gravitational lensing also produces some truly stunning images. The universe is full of incredible beauty, and gravitational lensing is a reminder of that. When a massive galaxy cluster distorts the light of a background galaxy, it can create images that are both strange and beautiful. These images are not just interesting from a scientific perspective, they're also works of art. The swirling shapes and vibrant colors are a reminder of the incredible power and majesty of the natural world. Some of the most stunning examples of gravitational lensing can be found in the Hubble Ultra Deep Field and the Hubble Extreme Ultra Deep Field. These images show a tiny patch of sky in unprecedented detail, revealing hundreds of galaxies that were never seen before. The images are so detailed that they reveal not just the distribution of matter in the universe, but also the distribution of dark matter. They read a testament to the power of gravitational lensing and the incredible capabilities of the Hubble Space Telescope. So the next time you look up at the night sky, remember that what you're seeing is only a tiny fraction of what's really out there. Behind the stars and planets, behind the galaxies and nebulae, there's a vast and mysterious universe that's just waiting to be explored. With the help of gravitational lensing, astronomers are able to see things that were never seen before and learn more about the fundamental nature of our universe. And who knows what other wonders and mysteries they'll uncover in the years to come. Now, while we may never fully understand the complexities of the universe, there are some things in life that are easy to understand, like the fact that everyone needs a good night's sleep. It's designed to help you fall asleep faster and stay asleep longer. You might be wondering how this works, and it's pretty simple. That's where comes in, with over 40 million downloads, is the best way to learn something new and make your existing knowledge more accessible. So, if you've ever wanted to learn about sleep, whether it's improving your sleep quality or understanding the science of dreams, has you covered. Plus, with new lessons added each month, there's always something new to learn. The best part is that it's free to download and easy to use. You can learn at your own pace and on your own schedule. Whether you want to improve your sleep quality, learn about the latest scientific discoveries, or simply expand your body of knowledge, has something for everyone. So why wait?